So we have an equation here, like we always do in maths, because maths, it has two real solutions. We're given one of them, and we're looking for its friend, right? Finding the other solution. What's maybe a bit tricky about this one is we have this random letter just popping up here, k. Like, why are you in my quadratic? I don't know, but there it is. So how do we approach this? So we know one of the solutions. Right. So we can use that information to find k. And once we have k, then we just have a normal quadratic equation and we can solve like normal. All right, so that's one way. And then I'll show you another way, which is called equating coefficients, which is a very powerful tool when dealing with polynomials or quadratics like this one. So first off, having a solution to a quadratic, let's think what that means. So graphically, two real solutions, right? Those are our x-intercepts. So when we have a solution, let's say x equals 3, the quadratic will evaluate to a y value of 0. Right? In this case, what we can do is substitute in our solution of 3 in for x, and we know, just plugging it into this equation, right? Substituting in 3 in for x, so we know it's a solution, so this is valid. We can then solve for k. Right, so this little picture over here is just showing us graphically what that might look like, but actually we don't even need to worry about that, because we know since x equals 3 is a solution, plugging it into the equation will hold, like it'll be true. So we can try now work out k. So 3 squared is 9. 9 times 3 is 27. Plus k times 3 is 3k. Minus 12 equals 0. 3k equals 27 minus 12 is 15. Now we subtract 15 on both sides. Now we can divide both sides by 3, which gives k equal to negative 5. So we found k. Now we can substitute k back into our equation. So instead of plus kx, we have minus 5x minus 12 equals 0. And now when we get to here, we have a standard quadratic equation that we can then solve to find out the value of x, right? The solutions, we know one of them will be x equals 3, and we can find the other one. Right, but I'll pause there. You can solve that on your calculator if you want, or factorize it by grouping. But let's look at another method. So this one's called equating coefficients. Equating coefficients. If we know one of the solutions is x equals 3, we know x minus 3 will be one of the factors if we were to factorize it. And in the other bracket, let's have a think. So to get 3x squared, this term must be 3x, right? X times 3x is 3x squared. So that works out. However, we don't know what this term will be, right? It's an unknown. That's actually what we're looking for. So let's call that P. P, because that's a problem right now. Now, from here, we can expand this out. So let's do that. So 3x squared plus bx minus 9x minus 3p. And now let's just group the like terms. So the x's right, would be x, and we're left with p minus 9 minus 3p. Now, this expression is actually equal to our original function, right? So we say equal to 0, but 0 is also equal to 3x squared plus kx minus 12. All right, so now what we do is called equate coefficients. So notice 3 does equal 3. Great. So I looked at the x squared term, and 3 does equal 3. Let's look at the x term. So this says k must equal p minus 9. Right, so looking at the coefficients of the x term. Finally, looking at the constant, minus 3p equals 12. Equals minus 12, excuse me. Which means p equals 4. And if p equals 4, k equals p, which is 4 minus 9, which equals minus 5. Which is exactly what we got using the other method. All right, but we don't even need to find k here, because looking back at our factorized form, we found p as 3x plus p, and now we can solve for x, right? So x equals 3 is one solution, and 3x plus 4 equals 0, 3x equals minus 4, x equals minus 4 on 3 is the other solution. So to summarize this one, equating coefficients, we know that one solution was x equals 3, so reverse engineering it, right, the factorized form, one of the brackets will be x minus 3. We know the other bracket will have a 3x in it to give us 3x squared, but we have some unknown, like plus p. And now we expanded that and then equated it to our original quadratic equation and then solved for p. We were able to solve for k as well, but we actually just needed p, because then we substituted in p equals 4 into our factorized form, and then we're able to solve for the other solution. So yeah, either method, perfectly fine. Would recommend learning how to equate coefficients because it's a very versatile tool.